So without further ado, I'm just gonna advance into some of our introductory material. So the IQ5 was introduced early this year. We had done mountains of feedback from our customer base, investigating what they wanted to see in the next innovation coming for the IQ platform. Within that investigation, we found that there was a need for a 4-laser system. So a lot of customers were seeking to do more multiplexing or utilize different markers more flexibly. So we introduced a 4-laser system, which is the IQ5. That 4-laser system has up to 25 color channels that you could test, and also FSC and SSC, which we'll reference a little bit as we get into things. We're super excited also about all the quality of life improvements that will help our customer base and all of the users really function with the IQ platform and get more out of their time. So giving you a little history of the IQ systems. So we have here 3 different configurations. We have our VYB, VBR, and BR systems, which represent 2 and 3 laser configurations for the violet, blue, and red lasers. So that system was then combined to include the yellow laser, giving us a VYBR IQ5 system. That 4-laser system, as I mentioned, has 4 lasers, 25 colors, plus the FSC and SSC. What that allows us to do is provide those users of the IQ system with up to 27 channels. They can have added functionality for multiplexing, increased flexibility for setting up workflows, even with a couple of markers that they might be screening for antibodies or other. The other thing that we've provided here is really accelerated our market leading speed. We were one of the fastest in the market. We will continue to be so, and this system makes sure of that. The other thing that we've added is a much more flexible workflow support. So you'll find as you work with the instrument, you can manage maintenance, you can manage workflow setup, you can manage some of the daily tasks a little bit easier, as that's some of the functionality that we've improved for quality of life. Effortless operation is something that customers love about our system, and we've done an improvement. Over 80% of the fluidics has been updated. We've made sure that we could get a larger volume for acquisition, so the same amount of time might be had between IQ3 and IQ5, but you're going to collect more sample on IQ5. So we're super excited. I think we've heard really positive feedback about that update so far. Improved clog detection and some of our air gap monitoring sensoring capabilities have been added to the IQ5 system as well. That won't make as much sense yet, but when I talk about it in the future, you're going to now know what that includes around effortless operation. Including more powerful and intuitive software, Foresight has always been one of the key foundational points for IQ. We didn't want to change that too much. We wanted to build upon it and improve that foundation even more. So you can now set up individual channel gains. So many customers were locked with an IQ3 system and they wanted some more flexibility. So we've added that degree of flexibility. So now you can function pretty much as a standard user who can go up and just plug and play. Or if you want to get in advanced settings and change the gains and work to increase your signal if it's dim or decrease it if it's too bright, you can go in and do that in advanced settings. We also have enhanced data analytics to allow us to do more with the Foresight software that we offer. And many of our customers are using automation or investigating automation to be utilized in their workflow. We've been able to add a updated QMAX system, which includes a trolley, which can now be rolled back and forth. But also, if you don't want to lift up the waste container to empty it, there's now kind of a little nozzle that comes off, and you can empty that directly into your waste. So we've tried to take some of that added functionality as well from the IQ5 into our QMAX system. Taking a step back, I do want to take a moment just to describe what the system is for those that might not be as familiar. The IQ systems are really built on this foundational principle around the patented flow cell. So we're very different from traditional flow. So as you come in and you look to see how samples are being collected, this is kind of a cross section of a 96-well plate. As you can see, as you collect sample, That sample is collected. It then raises the needle up. You get an air gap. It comes back down, collects sample. So what that creates is something that the software can take and analyze as an entire file, looking for sample versus non-sample plots. So you can see over time, we collect sample, we have our air gap, collect sample, air gap, all throughout time. You can set up customized protocols within the IQ system, which can wash it, which can really lead to almost essentially no crossover between our wells. There's a lot of play in which you can put into this system for optimizing your workflow. Again, this is one of the key features that makes the system as fast as it possibly can be, especially compared to our competitors. Talking a little bit about some of the IQ5 4-laser updates. As I've mentioned, the laser configurations are updated to include violet, blue, red, and a yellow laser, which all contain about 25 different color channels that you can utilize. We listed some examples of different fluorochromes or dyes that you could use within this context to multiplex and create a system or a panel that can really be designed for your workflow. This fourth laser, as I've mentioned a few different times, provides the flexibility that customers are looking for in screening, but also if you're doing immunotherapy or immunology screening, sometimes you need that additional channel to be able to do the truly complex work that you're looking for immunological assays. A little bit more about some of our collection criteria. When we redesigned the system, I've mentioned we did about an 80% change in the fluidics. Nothing is really major in terms of the change, but we have perfected it, I would say, in a better capacity. So we've optimized that fluidics flow so that if you look at the speed of acquisition on IQ3 versus IQ5, we are faster. We can collect a bit more sample. We also can see a reduced carryover. So without doing any washes, washes are a bit of a cheat there because you're really washing out anything that could be in the probe. But without that, even if you're looking at direct carryover assays, you can see if we do this assay looking at peak 2 and peak 4, those are two different bead configurations. We can analyze the carryover that happens when you alternate those wells of bead 2 and bead 4. So as you look between those two, you can see that the carryover is reduced on IQ5 in both of these capacities, whether you're looking at 2 or the 4 peak option, which is fantastic. So what we're stating here is that you could really go up to 2.2 microliters per second for an acquisition speed, collecting about 2 times the amount of data. Of course, if you are running something that's a typical type of assay, that can be up to 2,400 events per second more. So it's really adding to screeners' value per second. They're getting more data out. They can really utilize that to advance their projects faster. As well, we did optimize this fluidics to address some well ID. As I've mentioned in the introductory slide, when we talked a little bit about the air gap technology, it's going to go through and it's going to identify sample, air gap, sample. That system works very well. However, the software needed to be updated to really be able to consistently identify those samples. That has been updated, and I think we're getting a great overall response for well ID and consistent air gap recognition. Again, the well ID and air gaps, just some further testing for a 384 well and a 96 well format. And lastly, I did want to talk a little bit about some of our improved clog detection. So we've approached the new system in kind of 3 different ways. One is clog prevention, making sure that we could prevent any clogs from occurring in the first place. Nobody wants to face that, whether you're on a traditional flow cytometry system or screening. Especially in screening situations when you're lining up plates that can go overnight, you don't want to face anything that could be a potential clog situation that could disrupt the assay and even delay your workflow and delay the data that you're going to collect. So prevention, first and foremost, we added to it a visual coming for performance, and that's really called the bubble sensor or the air gap sensor. What that does is it provides this visual check, which is a blinking light that blinking light goes on, and you can see it consistently registering here as sample runs across it. It gives that visual that the system is performing adequately. The other element that I would address here as well, we want to be able to provide clog detection. So there's this visualization of performance and clogs that might be happening, but also now it's taking one step further, and we can do clog detection and give some type of a readout to the user. So if you look here, you can set a different number of functions here. So if you want to be truly sensitive to any clog that might be forming, you could set it at max. If you're really running an overnight run and you just want the system to notify the user if it develops an extreme clogging situation, that can be reduced all the way to minimum. The system really functions on integrity of the sample and the bubble that comes through. So that system is really outlined pretty clearly within our software so that we can register sample and air gap and make sure that the ratios, the intensity levels of those are adequate. And if it's not, that gives us a system where we can then alert the user and show a warning, or we could actually stop the run. So we're pretty excited to launch this as a new feature. We know that customers were running long assays within the IQ system, and we didn't want those systems to be inhibited by any clogs that might be forming. The other thing to mention about the new IQ5 system and how this advanced fluidics or the improved fluidics is helping us out. We've also updated part of the engine so that we can really look at an improved range of particle size. So the dynamic range is about 10 to the 7th in the original system. Now it's 7.2, which gives us a pretty broad set that we can look at. So there was already an improvement based on traditional flow where you could look at beads and cells very easily in the same workflow and the same visualization within the IQ platform. Now you can look down to about 0.2 microns up to 50 within the same view on your IQ. So again, that just allows us to look at smaller particles. If you look at our IQ3 in older generation systems, they're still good, and they'll be about 0.5, but the 0.2 really allows us to go down and utilize other systems that might be nanoparticles or yeast or different types of smaller particles that come into the system. They can now be analyzed and interpreted through IQ5 as well. I touched a little bit on the IQ QMax workstation. So as I mentioned, this system really extends the workflow from 7 hours to 48 hours. It has a huge sheath container here, which provides sheath to the system. As you can see, it's now in a trolley system. That trolley can be pushed around for unloading or emptying waste. When you get to the point where you do need to empty your waste, you'll see this nozzle here that can be detached and simply pulled over and emptied into your waste containment system. Again, the same outlook for our QMax controller. That's going to be updated a bit on branding, but pretty much the same look on the top. That system is just controlling the workflow so that you can pretty smoothly transition between the QMax system and the ERS or the fluidic station and the fluidics bottles that are on the system. So there's really no delay in you being able to transition fluidics. You can essentially never interrupt your workflow. I did want to talk a little bit about one individual case study. That case study is really going to focus in on immunology and looking into T-cell and CAR T-cell characterization and activation. So one of the key elements that we developed before Laser System 4 was this enhanced view that you could multiplex more. You can build up to a 24-channel panel. The interest in that is really for immunologists. So now you take something like CAR T and T-cell. You're looking for typically 4 to 6 types of phenotype or function assays. You'd be looking as well for some type of a functional marker. So something like CD69, looking for activation, looking for even maybe co-inhibition or co-activation like CTLA4. Those kind of things all take up channels and they need to be added to the panels as you're building them. So the next case study is really showcasing how the IQ5 system can be utilized to run that panel in a higher plex setting on the IQ5 system. So we've utilized as well one of our easy panel tools. What this tool is, it's available on the Sartorius website. You can select the IQ system or configuration that you have. That system can be entered, and then you can essentially customize the panel that you want to develop within that system. So what you'll do is select your configuration, and then you would start to line up each of the types of dyes or channels that you want to utilize and what type of markers you might want to utilize. You essentially can provide it with no information or basic information, or you could really get detailed on what you want to see. So we had some degree of knowledge of what we wanted to create here for a T-cell panel to replicate what our customers are doing in our customer visits that we're running. So typical assays would include a pretty standard set of CD4, CD8 for just looking at the phenotype, some CD69, CD62, CD25 for more of an activation status. You have CCR7, PD1, LAG3, TIM3 for more of your co-inhibition, co-activation statuses. And of course CD3 as well for identifying T cells. So that's a pretty typical panel that you might see for analyzing CAR T populations. We're using human peripheral blood mononuclear cells, or also known as PBMCs. Again, you can be activating these cells pretty easily with a cocktail of CD28, CD3. That'll activate any of the cells in the population, and then we'll isolate out CD3 positives and then look to see how they are activated in the entire population. So as you can see here, we've demonstrated this a little bit easier within some traditional overlay plots. So you can see unstained in lighter gray, controls in the darker gray, and the activated PBMCs with that CD28. As you can see with CD69, you're seeing a movement of the population over to the right, which means that's becoming activated. When you look at just those singlets, which is what we're looking at currently, you can see also the activation of CD25 as it moves to the right as well. We've summarized some of these markers for CD69, CD25 in different population subsets over here to the right. As you can see, the activated status shows increases in those markers, where your non-activated does not show it. Again, this is a case study for how this could be utilized for customers using or users running T-cell panels for CAR T-cell investigations. One of the things that they typically look at is exhaustion, so looking to see if cells have used up that capacity to activate. And part of that marker is really functioning with the co-suppressive markers for PD1, TIM3, LAG3. And you can see here, all of those also have some increased marker expression within the activated T-cell population. Lastly, a little bit of the memory phenotype that you might be looking at. Again, just showing proof of concept. What could we show to make sure that we could see differentiated cells? This panel really is showing 7 different profiles of kind of activated T cells. So you can see those updated here in the top. And we've given our basic population percentages. And you can see this panel could be expanded further to enhance or incorporate other types of markers, but it really gives a lot of information already. Again, for further information on this specific case study, you can utilize our one-pager that could be downloaded or available within the Cytometry Handbook. But hopefully it gives you an idea of what could be offered within the IQ system and how you could utilize IQ5 and that increased channel capacity to do more with your system. Again, I'm going to turn it over to our FAS. That is Catherine Geist, and she will be able to go through a little bit more. So turning it over to Catherine, and we'll learn a little bit more about IQ5. Thank you.
So my name is Katrin Dienst. I'm a field application specialist and supporting product management team today in introducing you to the IQ technology with its newest edition, the IQ5 VYBR system. I would like to focus today on one specific case study in the field of immunology. With the increased interest in cell therapy, there is a demand for efficient and rapid phenotyping of immune cells. Efficient and rapid, what does that entail? It's not only the speed of acquisition, it also means the complexity of the assay and the information that you get from very precious samples. If we think about T-cell or CAR T-cell activation assays, you may require several markers for phenotypic analysis. This could be CD3, CD4, CD8, and then activation markers like CD69 or CD25. For more comprehensive analysis, you may also want to add exhaustion markers or memory markers. All of these different markers need to be assigned to channels and to be introduced in your panel design. It is therefore essential to have a system that offers you sufficient channel and also tools that help you with panel design and also analysis of all of these different endpoint assays. One key aspect of the IQ5 system is the enhanced viewing. What we mean by that is not only the number of channels and lasers that we offer, but also the quality of the assay. For that, the IQ5 utilizes silicon PMs, which are today the preferred detectors as they give you the best signal-to-noise ratio. You can further adjust gains to your needs to combine high expression marker quantification with low expression markers. All of that needs to be taken into consideration when you are building your panel. So today I would like to show you a new tool that we are offering on our webpage to help you customize panels. I would then like to show you how we use one of these panels for the characterization of T-cell activation. On our webpage, you will find Easy Panel that will help you build your customized panel. You can start by selecting the cytometer configuration, and I was choosing here the IQ5 VYBR system. Easy Panel is highlighting you again the laser configuration that is offered with this configuration: violet, blue, yellow, green, and red. It also shows you the filters that are available and that will help you assign fluorochromes into this panel. If you're not working with the IQ5 yet, Easy Panel is also supporting previous configurations of the IQ system. We are then building here our own panel for T-cell activation with the information that we collected from our customers on typical markers used. That entails phenotypic markers like CD3, CD4, and CD8, activation markers like CD69 and CD25, exhaustion markers like PD1, LAG3, and TIM3, and memory markers like CD62 and CCR7. Easy Panel here once again highlights how the fourth laser really increases to help with the flexibility in design and the ability to capture more data. The panel shown here does have typical markers and should be a panel that you often see when T-cells are analyzed. However, it is not using the full extent of the cytometer offered in the IQ5 system, but you could add additional markers or assays, as I will show you later on. The panel was then used to characterize human peripheral blood mononuclear cells, or PBMCs, that have been activated through anti-CD3 and anti-CD28 antibodies. These cells were analyzed 48 and 72 hours post-activation. We are showing here different plotting options on how to isolate live cells and CD3 positive cells. The CD3 positive cells were then further subdivided into CD4 and CD8 positive populations. These populations were then characterized in their activation profile. We are using here overlay histograms to simplify representation. You can see in light gray the unstained samples, in dark gray the control PBMCs that have not been activated, and the yellow peak represents activated samples. You can see how the yellow peak shifts to higher intensity in both CD69 and also CD25. The assay has been performed 48 and 72 hours post-activation. In the bar graph on the right-hand side, we are summarizing these results. The non-activated samples show mostly very little to non-signal in the activation markers. The activated samples, however, are positive in both CD69 and CD25. Note how the CD69 signal, which is a marker for early activation of T cells, reduces over time, while CD25 remains high. You can imagine, with all the gating that I showed you here and the different time points, that the analysis requires dedicated tools. Another key element that we are offering is Foresight software that helps you analyze and visualize data sets. The cells were then also characterized for exhaustion markers. We are using here PD1, TIM3, and LAG3. All three of these markers are well known to be transiently increased after activation. And indeed, we can see that on activated samples, represented here in the yellow peak, all three markers can be detected, whereas the negative controls remain at lower intensities. 48 hours post-activation, these markers probably do not correlate with exhaustion yet, as this typically requires several rounds of activation. Yet we can all identify them as described in the literature. How can we then test if the cells have differentiated? And I would like to lastly address a memory phenotypic assay as a proof of concept. Here we are utilizing the markers CCR7 and CD62. The central memory T cells are positive in both of these markers, whereas effector memory T cells lose both markers. And you can see on the plot on the left-hand side how the negative control samples do show increased presence on the top right of the plot, correlating to central memory T cells. Whereas the activated PBMCs shift to the lower left corner, where we would expect effector memory T cells. The 7-channel panel can easily expand it to comprehend more markers or additional readouts. One optional readout could be a QBEAT assay that we offer for beat-based quantification of cytokines levels. The cytokines are quantified in the supernatant of the cells, and this can be easily combined in a one-to-no-wash assay together with a cell surface expression. But even without these additional markers or QBEATs, the assay already offers you up to 21 readouts and gives you a first idea of how cells are differentiated.